In reality, there was nothing. There was no Earth, no stars, no galaxies, no matter, no energy, not even space. The Big Bang didn't happen in outer space, because space itself did not exist either. Time was not passing, because there was no such thing as time. Out of this nothingness came a fireball, even smaller than an atom. It is trillions of times hotter than the sun's core. The universe, our world, plants, animals, and even the water that will make us up came out of a point smaller than the atomic nucleus. Time has begun. The events that took place after the Big Bang took place in such a small period of time that in order to both analyze and make sense of what was happening, scientists invented a new time unit called Planck time. This unit of time is so small that it is even impossible for us to imagine it. One Planck time means minus 43 seconds over 10. When we think about it, decimal number order, there are 42 zeros followed by the digit 1. Can you imagine it? The future, the password, the image of the entire universe were formed in such a small period of time, and it determined the next 13 billion years. From this fireball, which appeared with a large explosion, four basic forces of nature were formed. These were gravitational force, electromagnetic force, weak nuclear force, and violent nuclear forces. And without these forces, the universe will be a featureless cloud of radiation. These four basic forces are still functioning. Gravity orbits the planets. Nuclear forces are making the stars glow. And it creates the light that rains down on our universe, electromagnetic radiation. The universe consists of an elegant union of more than 2 trillion galaxies, each of which contains 200 billion stars. And our world is now the only planet on which we know that there is living life. But we can't even estimate the number of other planets in the universe. You can tell by the length of the sound waves emitted by this planet that an airplane is approaching or moving away from you. When scientists first discovered that the universe was expanding, they understood it by looking at the wavelengths of light sent by distant galaxies, such as sound waves from the same plane. An object was turning blue as they approached it and turning red as it moved away. Astronomers learned about the distance by observing the degree to which an object appears red. The Big Bang theory is generally accepted theory by scientists. This concept appeared less than 100 years ago. It used to be believed that the universe is infinite. It has existed since time immemorial. But today's observations show that all galaxies are moving at a speed of 1.6 million kilometers per hour. If the galaxies are moving away from each other, it means that they were all together in the universe is expanding outward from a certain point. This is the first evidence that the universe has a beginning. The second piece of evidence was discovered in the 1960s. At Bell Laboratories in New Jersey, scientists had built a giant antenna to communicate with other satellites. This antenna converts sound waves into electricity and into light in the form of microwave and radio waves. In 1964, while looking at the radio waves found in gas clouds on the Milky Way with the Horn Antenna Radio Telescope, they noticed that there was constant interference, and this sound was coming from all directions. They thought something was wrong with the experiment, but the sound didn't stop. They started looking for the source of the sound. They realized that radiation is something that is not on Earth, but actually comes from the depths of space, and it comes from everywhere. This was the echo of the beginning of time. The Big Bang was so strong and so hot that the remnants of this heat cloud still be found. This weak radiation, which constantly reaches the Earth, is called cosmic microwave background radiation today. A meaningless blank screen that appears when you scroll through channels on a TV is actually some kind of documented image from a Big Bang. So how did it turn into matter when the first state of the universe consists of pure energy? We know that everything around us consists of matter and the atoms of matter. The air we breathe, our homes, our cars, our food. The appearance of the substance was a secret until 1905. The Albert Einstein came up with this famous equation, E equivalent mc2. Mass and energy were interchangeable. Some scientists later used this equation to create the deadliest weapon in history, an atomic bomb. And this gave an idea of what happened at the first moment. In a nuclear explosion, the particles of matter separate from each other to create a colossal amount of energy. After the Big Bang, the opposite happened. Some of the huge energy turned into matter. Einstein's equation revealed one result. As the infant universe grew older and colder, the pure energy of the Big Bang decays into the parts of matter that make up us. Everything around us is made up of substance created by the energy released by the Big Bang. Every molecule, every atom, every quark. After the appearance of matter, over billions of years, huge clouds of gas and dust have decided together to form galaxies. Galaxies have formed a star system, and star systems have formed planets. Finally, vitality has appeared on some of these infinitely many planets, and today we, the most advanced species of these organisms, have begun to understand and reveal all these galleries and secrets of the universe. We have begun to uncover the secrets of the universe, but we are still at the beginning of the road. After all, we can't get out of this three-dimensional world we are in. If we could go to other dimensions, who knows what else we could discover. According to string theory, the way to combine all types of particles in the universe is to accept that there is an 11-dimensional space. There are 7 other dimensions that are invisible to the eye except for the 3-dimensional space and 1-dimensional time that we are perceiving. Since these dimensions have turned on themselves like an ellipse or a bagel, they form a complex space-time structure. The universe, which was extremely hot at the time of the Big Bang, consists of a single space dimension. In the universe, what we call it, space consists of a line with no width and 2-dimensional Euclidean geometry. This is flat geometry, was enough to define space-time. As the universe cooled down, it expanded and opened like a lathe in space, forming a 2-dimensional plane. Today we can see 4 dimensions in the universe along with length, width, height, and time. The other 7 dimensions are widened from view. However, new calculations show that as the universe ages, the number of dimensions we can see will increase. So, what is the 4th dimension? Fifth, unfortunately, when we say size, our brain fails to even imagine it. Time dimensions aside, it is the 4th dimension of the 3D world we are in. What can it mean to go into size? As an example of 4th dimension, we can show a truth. At this size, you can only go back and forth. An example of 2nd dimension can be a square. When we move the 3rd dimension, it gets into the work at the depth and it's not possible for you to move back and forth, left and right, up and down. So, what kind of direction comes into play in the 4th dimension? We don't know about it, but his hypercube, named tesseract, is representative of it. Its size allows us to imagine it a little bit, but of course it's really 4th. It will never be possible for us to understand the size, because our perception, our sense do not allow this, and the universe we live in is a 3rd-dimensional universe. So, what will happen if we live in a 3D world? And then, third, we could not even imagine it this size.